Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic, indices. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to understand and apply the laws and properties of indices. You should be able to solve equations involving indices. So in our study on indices, we are going to concentrate on the laws and properties of indices. Then we are also going to learn how to solve equations involving indices. So let's begin by learning more about indices. Index form of notation is a simple way of writing numbers. Index is the singular form of indices. So index is singular and indices is plural. The point here says that index form of notation is a simple way of writing numbers. So for example, 2 times 2 times 2 can be written in the index form as 2 with the number 3 on top of it. So you can see from here that 2 is being multiplied 3 times. So 2 times 2 times 2. In the index form, it's written as 2 with the number 3 on top of it here, meaning that 2 is multiplying itself 3 times. When we write a number in the index form like this, 2 is referred to as the base, and 3, the 3 on top here, is referred to as the index. So 2 is the base and 3 is the index. The index tells you the number of times you need to multiply the base number together. So here we have 2 to the power 3, or 2 with the number 3 on top of it, which means that 2 is the base and 3 is the index. The point here is saying that when you look at the index, it tells you the number of times you have to multiply the base number together. So here 2 has the index 3, which means that we have to multiply 2 together 3 times. So you have 2 times 2 times 2. So the index gives you an indication or tells you the number of times you need to multiply the base together. The index is also known as power or exponent. So in this case, this number can be read as 2 exponent 3 or 2 to the power 3. So this 3 here is called index, power, or exponent. So here this number is read as 2 to the power 3, 2 to the 2 exponent 3. So it can be 2 exponent 3 or 2 to the power 3. Okay, let's pick some questions and see how to write numbers in their index form. So write the following in index form. You have been given 4 questions here. You will solve them one after the other. So we pick the first one. 7 times 7 times 7 times 7 times 7. So we have 5 of the 7s here. 1, 2, 3, 4, 5. So 7 is multiplying itself 5 times. So to write it in the index form, you write one of the 7s, then the power will be 5, or the exponent will be 5, or the index will be 5. Okay, so to write this in the index form, you pick one of the base numbers, then we count the number of 7s here. So 1, 2, 3, 4, 5. So 7 to the power 5. In the same way, when you see 7 to the power 5, it can also be written as 7 times 7 times 7 times 7 times 7. Let's pick the next question. We have y times y times y. This can also be written as, we pick one of the numbers here, so y, then to the power 3, because y is multiplying itself 3 times. So it means that here y is the base and 3 is the index, the exponent, or the power. The next one, we have 1 divided by 4 times 1 divided by 4 times 1 divided by 4 times 1 divided by 4. So we have the 1 divided by 4 is repeating itself 4 times. So you write 1 divided by 4, then to the power 4. As the study goes on, you understand why you have to put 1 divided by 4 in a bracket. We will explain that as the study goes on. So you have 1 divided by 4, you put that in a bracket, then to the power 4. Let's look at the last one. We have 3.7 times 3.7 times 3.7 times 3.7 times 3.7 times 3.7. So the 3.7 is repeating itself 6 times. So you have 1, 2, 3, 4, 5, 6. So you write one of them, 3.7, then to the power 6. So to write a number in index form, you write one of the numbers, then you count the number of times the number is multiplying itself, and you write it as the exponent, the power, or the index. Thank you for watching this video. Don't forget to like and subscribe to this channel if you haven't done that. In the next video, we are going to study the laws of indices. We are on the topic indices. In the previous video, we learned how to write a number in the index form. In this video, we are going to learn about the laws of indices. Let's consider the first law. The first law is called the product law. We know that product means multiplication. So what this law says that if you have two or more numbers multiplying in the index form and these two numbers have the same basis. Now remember, for this law to work, the two numbers must have the same basis. If the two numbers have the same basis, then write one of the numbers and add the exponents. So if you have two or more numbers, here we are just using the basic form, which is just two numbers. If you have two or more numbers that are multiplying in their index form, and the two numbers have the same basis, write one of the bases and add the exponents. So for example, if you have 3 exponent 2 times 3 exponent 7, write one of the bases, which is 3, and add the exponent, so 2 plus 7, and this will give us 3 exponent 9. In the same way, if you have x exponent 3 multiplying x exponent 2, you write one of the bases, which is x, and you add the exponent, so 3 plus 2, so this will give us x exponent 5. If you have 1 over 2 exponent 3 multiplying 1 over 2 exponent negative 2, you pick one of the bases, so 1 over 2, then you add the exponent, so you are going to have 3 plus minus 2. From algebra, we know that 3 plus minus 2 is 3 minus 2. So this one will give us 1 over 2 exponent 1, which is the same as 1 over 2. So all that this law says is that if you have two numbers that are multiplying in the index form, and the two numbers have the same basis, remember that is very important. If the two numbers don't have the same basis, you can't apply this law. So here, if this were to be 3, just as this is 3, if this is 3 and this is 5, you can't add the exponents. The two numbers must have the same basis in order to add the exponents. Let's consider the next one. It's called the quotient law. Quotient means division. So in the previous slide, we considered multiplication. We are going to consider division here. Now, if these two numbers are dividing and they have the same basis, the quotient law says that write one of the bases and subtract the exponents. So in the other one, we are adding the exponents. So if it's multiplying, you add the exponents. If it's dividing, you subtract the exponents. So for example, if you have 10 raised to the power 7 divided by 10 raised to the power 4 is equal to 10, you write one of the bases, then you subtract the exponent, so 7 minus 4. So you subtract the exponent of the denominator from the exponent of the numerator, so 7 minus 4, and this will give us 10 exponent 3. If you have 5 exponent 3 divided by 5 exponent minus 2, it says that you write one of the bases, so 5, then you subtract the exponent of the denominator from the exponent of the numerator. So you have 3 minus 2. We know that 3 minus 2 from algebra is 3 plus 2. So this will give us 5 exponent 3 plus 2, which is 5 exponent 5. If you have y exponent minus 3 divided by y, we know that this is the same as y exponent minus 3 divided by any number that you see that doesn't have an exponent. It means the exponent there is 1. So there is no exponent on y here. It means it's raised to the power 1, or the exponent is 1. So this is the same as y exponent minus 3 divided by y exponent 1. We subtract the exponent of the denominator from the exponent of the numerator, and this will give us y exponent minus 3 minus 1, which is y exponent minus 4. Let's consider the third and last law. It's called the power law. What this law says that if you have a exponent x, then exponent y is giving us a exponent x times y, or a exponent xy. Let's pick some examples. So if you have 2 exponent 2, then that in brackets exponent 3 is the same as 2 exponent, the 3 will multiply 2 here, so 2 times 3, and this will give us 2 exponent 2 times 3 is 6. Okay, so if you have 3 exponent minus 6 into brackets, then another exponent, so exponent 4, is equal to 3 exponents. The 4 will multiply the minus 6, so minus 6 times 4, which will give us 3 exponent minus 24, because minus 6 times 4 is 24. If you have 7 exponent n, then that into bracket another exponent 2 will multiply n. Remember, if you look at it very carefully, you will see that the exponent is not multiplying the base, it's multiplying the exponent. So you multiply the two exponents, so 7 exponent n times 2. From algebra, we know that n times 2 is 2n, so this will give us 7 exponent 2n. Thank you for watching this video. We learned how to use the power law, how to use the product law, and how to use the quotient law. In the next video, we are going to learn about the properties of indices. We are on the topic indices. In the previous video, we considered the laws of indices. In this video, we are going to learn about the properties of indices. We are going to consider 6 properties in all. So let's begin with the first property. The first property says that a exponent 0 is equal to 1. What this means is that any number exponent 0 or any term exponent 0 is 1. So for example, 5 exponent 0 is 1. X exponent 0 is 1. 1 over 4 exponent 0 is 1. So any number exponent 0 or any term exponent 0 is 1. This is the first property. Let's consider the second property. The second property says that if you have a multiplying b in a bracket like this and it's raised to the power x, is equal to a exponent x times b exponent x. So you give this exponent x to a and you give the exponent x to b. Remember that the two numbers are multiplying. You can't do this when the two numbers are adding or subtraction. So if the two numbers are adding or subtracting, you can't do this. It has to be multiplication. This law is for multiplication. So if you have a times b into brackets exponent x is equal to, you give the exponent to the first one, then you give the exponent to the second one. So a exponent x times b exponent x. Once again, you can't do this when it's addition or subtraction. This property is for multiplication. Okay, so for example, if you have 2 times 3 exponent 2, you are going to have 2 exponent 2 times 3 exponent 2. So you give 2 to the first one, then you give the exponent 2 to the second one. So you have 2 exponent 2 times 3 exponent 2. If you have 5 times 7 into brackets exponent minus 1, you are going to have 5 exponent minus 1 times 7 exponent minus 1. As our studies goes on further, we are going to learn how to simplify this. Okay, if you have n times m into bracket exponent 3, you are going to have n exponent 3 times m exponent 3. If you watch the video on algebra, you will see that this is equal to n exponent 3 m exponent 3. So this is the second property. Once again, look at the property very well. We can only do this when the two numbers in the bracket are multiplying. This property is for multiplication. Let's consider the third property. It says that if you have a exponent minus 1 is equal to 1 over a exponent x. Sorry, it says that if you have a exponent minus x is equal to 1 over a exponent x. Okay, so for example, if you have 3 exponent minus 2 is equal to 1 over 3 exponent 2. So you see, immediately we bring 1 over, then we write the number here as the denominator. The negative sign changes to positive. So you have 1 divided by 3 exponent 2. And this will give us 1 divided by 9. In the same way, if you have 4 exponent minus 1 is equal to 1 divided by 4 exponent 1. So if you write 4 exponent 1 as the denominator, the minus 1 changes to positive 1. And this will be 1 divided by 4. If you have x exponent minus 3 is equal to 1 divided by x exponent 3. So x exponent minus 3 is equal to 1 divided by x exponent 3. So you see from here, if you write 1 divided by, then we write this number here, the negative changes to positive. This property is very, very important. We are going to use it a lot in our studies on indices. So in this video, we have considered the first 3 properties of indices. In the next video, we are going to consider the 3 remaining properties of indices. We are on the topic indices. In the previous video, we considered 3 properties of indices. In this video, we are going to consider the 3 remaining properties of indices. So let's look at the fourth property. The fourth property says that if you have a divided by b into bracket x is equal to a exponent x divided by b exponent x. So for example, if you have 2 divided by 3 exponent 3, you are going to have 2 exponent 3 divided by 3 exponent 3. And this will give us 8 divided by 27. So all you need to do here is to distribute the x for a and for b. So you are going to have a exponent x divided by b exponent x. So in this example, 2, you distribute the 3 for 2 and 3. So you have 2 exponent 3 and 3 exponent 3. 1 divided by 4 exponent 2. This will give us 1 exponent 2 divided by 4 exponent 2. And this will be 1 divided by 16. So you give the 2 to 1 and you give it to 4. So 1 divided by 1 squared or 1 exponent 2 divided by 4 exponent 2. This will give us 1 divided by 16. Let's consider the fourth property. If you have a divided by b exponent minus x. So in the fourth property, we had a divided by b exponent x. in the fifth property is a divided by b exponent minus x. When you have this, what you do is that you reciprocate the fraction. So the numerator becomes the denominator and the denominator becomes the numerator. And when you do that, the negative here changes to positive. So this a divided by b exponent minus x is equal to b divided by a exponent x. Okay, so if you have 2 divided by 3 exponent minus 3 is equal to 3 divided by 2 exponent 3. This will give us 3 exponent 3 divided by 2 exponent 3, which is 27 divided by 8. In the same way, if you have 1 divided by 5 exponent minus 2, you are going to have 5 divided by 1 exponent 2. So you reciprocate the fraction. Then you distribute the 2 to 5 and 1. So you have 5 exponent 2 divided by 1 exponent 2. This will give us 25 divided by 1, which will give us 25. If you have y divided by x exponent minus 1, if you are applying this property, you are going to get x divided by 1 by y exponent 1, which is x exponent 1 divided by y exponent 1, giving us x exponent x divided by y. So all you need to do is to reciprocate the fraction, then you change the negative here to positive. So in this case, y divided by x exponent minus 1 becomes x divided by y exponent 1, which is x divided by y. Let's consider the sixth and final property. It says that if you have a exponent 1 over n, it is equal to the nth root of a. So a exponent 1 over n is equal to the nth root of a. For example, if you have 3 exponent 1 over 3 is equal to the third root of 3. And this is how you write the third root of 3. You write 3 as a small number here, then you write the square root sign and you write the number here, which is 3, under it. So the third root of 3, this is how you write it. So if you have a exponent 1 over n is equal to the nth root of a. In the same way, if you have 75 exponent 1 over 4 is equal to the fourth root of 75. So the fourth root of 75, you write 4 here, which in this case represents n. If you compare, you can see that 4 represents n here. You write 4 as a small number, then you write the square root sign and you write the 75 under it. This is the fourth root of 75. So if you see this anywhere, it means 75 exponent 1 over 4. In the same way, if you see 75 exponent 1 over 4, it can also be written as the fourth root of 75. If you have xy exponent 1 over 5, it means the fifth root of xy. And this is how you write it. You write 5 as a small number, you write the square root sign, then you write xy. Make sure that you don't write it like this. This is what I mean. Make sure that this, in this case here, you don't write it as 5, then square root of xy. This is wrong. This is 5 square root of xy. This is 5 fifth root of xy. So the 5 should be written as a very small number. Then you write the square root sign and xy under the square root sign. Okay. So this is the sixth property. Now let's consider this. If you have this time n is 2, so you have 5 exponent 1 over 2. This will give us the square root of 5. And this is how to write the square root of 5. So you write the square root sign 5. So if n is 2, like you see here, you are not going to write 2 as a small number here. You only do that when n is 3, 4, 5, and so on and so forth. So if it's 5 exponent 1 over 2, it is written as the square root of 5. So if you have here, if n is 2, then your answer is the square root of the number. Okay, so 5 exponent 1 over 2 is equal to the square root of 5. So if you have a exponent 1 over n, it's written as the nth root of a. Thank you for watching this video. We have considered all the properties and laws of indices. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to apply the laws and properties of indices that we've learned to solve some questions. We are on the topic indices. We have considered the laws and properties of indices in the previous videos. In this video and the subsequent ones, we are going to apply the laws and properties of indices that we've studied in the previous videos to solve some questions. So we have 4 questions here and we are going to solve them one after the other. We will solve the first one in this video, then we will solve the others in the subsequent videos. So let's take the question for this video. We have 5 exponent 6 times 5 exponent minus 3 divided by 5 exponent 4. So since this is a fraction, we will solve what is on the numerator, then we will solve the denominator. After that, we will add everything. Okay, so 5 exponent 6 times 5 exponent minus 3. We learned from the laws of indices that if you have two numbers in index form multiplying, and these two numbers have the same basis, you write one of the base and you add the exponents. So here we have 5 exponent 6 multiplying 5 exponent minus 3. They have the same basis, so you write one of the bases, then we add the exponents. So 6 plus minus 3. 6 plus minus 3 will give us 6 minus 3. The denominator, we only have 5 exponent 4. So you write 5 exponent 4. So you solved what is on the numerator. This is going to give us 5 exponent 6 minus 3 will give us 5 exponent 3. So divided by 5 exponent 4. We also learned from the laws of indices that if you have two numbers in index form dividing, and these two numbers have the same basis, you subtract the exponents. So 5 exponent 3 divided by 5 exponent 4, you write one of the bases. So 5, you write one of them. So 5, then you subtract the exponent or the power of the denominator from the numerator. So the power of the denominator is 4. The power of the numerator is 3. So you subtract the power of the denominator, which is 4, from the power of the numerator, which is 3. So you have 5 exponent 3 minus 4. This is going to give us 5 exponent minus 1. We learned from the properties of indices that 5 exponent minus 1 can be written as 1 divided by 5 exponent 1, which will give us 1 divided by 5. So the answer to this question is 1 divided by 5. In an objective examination, if you are given this question, you don't have to go through the hassle of solving this whole thing here. You can just punch this expression on your calculator and your calculator will give you the answer. To do that, since this is a fraction, you press on the fraction button. Then you enter the expression. So we have 5 exponent 6. Okay, so 5 exponent 6 times 5 exponent minus 3. Then you divide this by 5 exponent 4. You press the equal to button and we have 1 divided by 5, just as we have here. So if this were to be an objective test, you just enter this expression on your calculator and the calculator gives you the answer. Thank you for watching this video. Don't forget to like and subscribe to this channel. At the beginning of this video, we had 4 questions and we solved the first one. In the next video, we are going to solve the second question. We are on the topic indices. In the previous video, we applied the laws and principles of indices to solve a question. In this video, we are going to solve another question. So let's look at our question for this video. 256 exponent minus 1 over 4 into bracket 255 exponent 1 over 2 plus 58 exponent 0. So to solve this question, we will have to change 256 to index form and change 225 to index form. We know that 58 exponent 0 is 1 from the properties of indices. So that is exactly what we are going to do. So we change 256 to index form and you have 4 exponent 4. There is minus 1 over 4 already here. So we are going to have 4 exponent 4 times minus 1 over 4. Then into bracket, we will change 225 to index form and that will give us 15 exponent 2. So we already have 1 over 2 here. So it's going to be 2 times 1 over 2 plus, from the properties of indices, we know that any number raised to the power 0 is 1. So 58 raised to the power 0 is 1. We can see from here that 4 cancels 4, 2 cancels 2. So you see that I changed these numbers to index form such that the index will be the same as the denominator of the fraction. So here the index is 4, the denominator is 4, so 4 and 4 will cancel. When you come to this side too, the index is 2, the denominator is 2, so 2 and 2 will cancel. Okay, so we've cancelled the denominators out, so we are going to have 4 exponent. We are left with minus 1, so minus 1 into bracket. When you come here to, we've cancelled the index and the denominator out, so we are going to have 1. So 15 exponent 1 is 15 plus 1. We learned from the properties of indices that 4 exponent minus 1 is the same as 1 divided by 4. 15 plus 1 is 16. So you are going to have 1 divided by 4 times 16. And this is going to give us 4. If you want to do this on your calculator, you switch on your calculator, then you enter this expression on the calculator. So you have 256 exponent minus, then you bring your fraction button 1 divided by 4. Then you bring your bracket open button 225 exponent, you bring your fraction button 1 divided by 2, then plus, so we have plus 58 exponent 0. Don't forget to close the bracket. So you close the bracket and you press on equal to sign, and the calculator solves the question for you. So if you have this question in an objective test, just enter the expression on your calculator as we did here, and the calculator will solve it for you. So this is the solution to this question. The solution to 255 exponent minus 1 over 4 into bracket 225 exponent 1 over 2 plus 58 exponent 0 is 4, as we can see here. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to solve another question. We are still on the topic indices. In the previous video, we used the laws and principles of indices to solve a question. So in this video, we are going to solve another question. The question for this video is 27 exponent 2 over 3 times 64 exponent 1 over 3 divided by 81 exponent 1 over 4. So we are going to solve this question. To do that, we will have to reduce 27 to its index form, we reduce 64 to index form, we reduce 81 to index form. When you do that, 27 in index form is going to give us 3 exponent 3. 64 in index form is going to give us 4 exponent 3. And 81 in index form is going to give us 3 exponent 4. If you take 27 here, we already had 2 over 3. So we are going to have 3 exponent 3 times 2 over 3. The same way for 64, we already had 1 over 3 as the exponent. So if we change it to index form, we are going to have 4 exponent 3 times 1 over 3. For the denominator part, 81 already had an exponent of 1 over 4. So if you change it to index form and you get 3 exponent 4, it's going to multiply the exponent 4 is going to multiply the 1 over 4 that was already there. Okay, so you can see that in each case, I changed it to index form such that the exponent is the same as the denominator of the fraction. So here, the exponent is 3, the denominator is 3. Here too, the exponent is 3, the denominator is 3. And for this part too, the exponent is 4, the denominator is 4. When you do that, you can cancel the denominators and the exponents out. So 3 and 3 will cancel. 3 and 3 will cancel, then 4 and 4 will cancel. Okay, so we are going to have 3 exponent. This 3 is gone, this 3 is gone, so you have 3 exponent 2 times, when you come here, 3 is gone, 3 is gone, we are left with 1, so 4 exponent 1 divided by, when you come to this side too, 4 is gone, 4 is gone, so we are left with 1. So we have 3 exponent 2 times 4 exponent 1 divided by 3 exponent 1. This can be written as 3 exponent 2 divided by 3 exponent 1 times 4 exponent 1 divided by 1. So it's like we have 3 exponent 2 times 4 exponent 1 as the denominator, as the numerator, then 3 exponent 1 times 1. We are going to have 3 exponent 1. So it's the same thing. We haven't changed anything. Okay, we know from the laws of indices that if you have two numbers in their index form dividing and the two numbers have the same basis, you subtract the exponents. So this is going to give us 3 exponent 2 minus 1. We subtract the exponent of the denominator from the exponent of the numerator. So we have 3 exponent 2 minus 1 times 4 exponent 1 is 4. 4 divided by 1 is 4. So this is going to give us 2 minus 1 is 1. So we are going to have 3 exponent 1, which is the same as 3, times 4. 3 times 4 is 12. So the answer to this question is 12. If you want to do this on your calculator, enter the whole expression that we have here on your calculator. So we have 27 exponent. Now the exponent is a fraction, so 2 divided by 3, then times 64 exponent. Here to the exponent is another fraction, 1 divided by 3. Then we come to the denominator part. We have 81 exponent. The exponent is another fraction, so 1 divided by 4. So we have the whole expression here on our calculator. You just enter equal to, and the calculator solves it for you, and we had 12, just as we have here. Thank you for watching this video. Don't forget to like and subscribe to this channel. In the next video, we are going to solve another question. We are still on the topic indices. In the previous video, we solved the question by applying the laws and principles of indices. In this video, we are going to solve another question. So let's look at the question for this video. Square root of 36x exponent minus 3 y exponent 3 divided by 4x exponent 3 y exponent minus 3. And we are supposed to simplify this expression here. We learned from the properties of indices that whenever you have a number or a term under a square root sign, it's equal to that number or term raised to the power half. So we can write what is under the square root sign here in a bracket, then we bring the exponent half on it, as you can see here. Now I'm going to group them so that I will be able to simplify. So I'll group the numbers and the letters. This will give me 36 divided by 4 times x exponent minus 3 divided by x exponent 3 times y exponent 3 divided by y exponent minus 3 raised to the power half, or exponent half. 36 divided by 4 will give us 9. We learned from the laws of indices that if you have two numbers or two terms written in the index form and these two numbers are dividing, you write one of the bases and you subtract the exponents. So we are going to subtract the exponent of the denominator from the exponent of the numerator. So here we are going to have x exponent minus 3 minus 3. Then times, we have the same thing here. So we write one of the bases, which is y, and we subtract the exponents. We subtract the exponent of the denominator from the exponent of the numerator. So this will give us 3 minus minus 3, which is 3 plus 3. We still have the exponent 1 over 2 here. So if we are simplifying, this is going to give us 9 times x exponent minus 3 times, x exponent minus 6 times y exponent 6 raised to the power half, just as we have here. We learned from the properties of indices that if you have something like this, we can distribute half to each of the numbers or terms here. So in doing that, we are going to have 9 exponent 1 over 2 times x exponent minus 6 times 1 over 2. Because we have minus 6 here, when you give the half to this, it's going to multiply the minus 6. So x exponent minus 6 times 1 over 2 times y exponent 6 times 1 over 2. Now, what do we do here? We are going to write 9 in the exponent form. We are going to write 9 in the index form such that we can simplify. So in doing that, if you write 9 in the index form, you are going to have 3 exponent 2, or 3 squared. So 3 squared is 9. We already have 1 over 2 here. So 3 exponent 2 times 1 divided by 2. Okay, we can see from here that 2 will cancel itself 1 and cancel 6 3 times. In the same way, 2 will cancel itself 1 here and cancel 6 3 times also. Okay, so it means that we are going to have 3 exponents 2 times 1 over 2 times, when you come here, 2 cancel itself 1 and cancelled here 3 times. So you are going to have minus 3 times 1, which will give us minus 3. So we have x exponent minus 3 times, here so we have 3 times 1, which is 3. So we have y exponent 3, as can be seen here. Just as we did for the step here, here too you are going to cancel 2 and 2. And in doing that, we are going to have 3 exponent 1, because 2 and 2 are gone, times 3 exponent x exponent minus 3 times y exponent 3. We learned from the properties of indices that any number exponent 1 is the same number, so we have 3 here. We also learned that x exponent minus 3 can be written as 1 divided by x exponent 3. So just as you've seen here, x exponent minus 3 can be written as 1 divided by x exponent 3 times y exponent 3. We know from fractions that any number that stands alone is divided by 1. So 3 here is 3 divided by 1. And in the same way, y here is y divided by 1. So we are going to multiply the numerators and we multiply the denominators. So we have 3 times 1 times y exponent 3. And that will give us 3y exponent 3. Then at the denominator part, we have 1 times x exponent 3 times 1, which will give us x exponent 3. So it means that if we simplify the fraction, if we simplify the expression, we are going to have 3y exponent 3 divided by x exponent 3. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to study how to solve exponential equations. We are still on the topic indices. You studied about the laws and properties of indices in the previous videos, and we've used these laws and properties to solve some questions. In this video and the subsequent ones, we are going to study about exponential equations. Exponential equations are equations with unknowns in the exponents. So if you have an equation with unknowns or variables in the exponents, they are called exponential equations. Exponential equations can be reduced to linear equations, quadratic equations, or simultaneous equations. To solve exponential equations, remember that if a exponent x is equal to a exponent y, then x is equal to y, provided that a is not equal to -1, 0, or 1. So to solve exponential equations, we need to remember that if the base of the term on the left-hand side is equal to the base of the term on the right-hand side, then we can equate the exponents and solve the resulting equation. So the main aim in exponential equations is to make sure that the base on the left-hand side is equal to the base on the right-hand side, so that we'll be able to equate the exponents and solve the resulting equation. But we need to remember that the base must not be -1, 0, or 1. So apart from -1, 0, or 1, if the base on the left-hand side is equal to the base on the right-hand side, then we can equate the exponents and solve the resulting equations. We learned here that exponential equations can be reduced to linear equations, quadratic equations, or simultaneous equations. We are going to start with exponential equations that can be reduced to linear equations. So exponential equations reduced to linear equations. We are going to learn how to solve these. So solve for x in the following equations. We have been given 5 equations and we solve them one after the other. We will solve the first equation in this video. So the first one is 7 exponent x plus 1 is equal to 343 exponent 4. As we've learned, the main goal is to make sure that the term on the left-hand side and the term on the right-hand side has the same base. The base on the left-hand side is 7. The base on the right-hand side is 3, 4, 3. Now when you have this, you see that we have 7 on the left-hand side and 3, 4, 3 on the right-hand side. You reduce the bigger one such that it has the base of the smaller one. Now this is what I mean. We have 7 on the left-hand side and 3, 4, 3 on the right-hand side. So we are going to reduce 3, 4, 3 such that it has a base of 7. We are going to reduce 3, 4, 3 to index 4 such that it has a base of 7. So this means that 7 exponent a certain number will give us 3, 4, 3. 7 exponent a certain number, we don't know that number. 7 exponent a certain number will give us 3, 4, 3. To help us find that number, we are going to use our calculator to do it. So you search on your calculator. We are looking for 7 exponent as a number that will give us 3, 4, 3. So let's start with 2. We know that 7 exponent 1 will give us 7. So let's start with 2 and see. 7 exponent 2 will give us 49. It's smaller than 3, 4, 3. So let's increase the exponent to, let's say, 3. 7 exponent 3 is giving us 3, 4, 3. So it means that the number we are looking for is 3. So we have come to see that 7 exponent 3 will give us 3, 4, 3. Okay, so now we can replace 3, 4, 3 in the equation with 7 exponent 3. So 7 exponent x plus 1 on the left hand side is equal to 343 is now 7 exponent 3. Don't forget that there's already an exponent 4 there, so 7 exponent 3 times 4. And this will give us 7 exponent x plus 1 is equal to 7 exponent 3 times 4 will give us 12. So you see from here that we now have the base on the left hand side as 7 and the base on the right hand side as 7. So we can now equate the exponents. Since the bases are equal, we can equate the exponents. So we will say that x plus 1, which is the exponent on the left hand side, is equal to 12, which is the exponent on the right hand side. So x plus 1 is equal to 12. You find x, you simplify this and find x. So x is equal to 12 minus 1, x is equal to 11. So when you are given an exponential equation, the main thing you need to focus on is that make sure that the term on the left hand side and the term on the right hand side have the same base so that you'll be able to equate the exponents. In doing that for this equation, we have x is equal to 11. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. At the beginning of this video, we had 5 questions and we've solved the first one. In the next video, we are going to solve the second question. We are still on the topic indices. In the previous video, we solved a question on exponential equations reduced to linear equations. In this video, we are going to solve another question. So let's look at our question for this video. We have 3 exponent x minus 2 is equal to 1 divided by 81. And we are supposed to find the value of x in this equation. We learned from the properties of indices that if you have 1 divided by 81, it can be written as 81 exponent minus 1, as you can see here. So this equation here can also be written as 3 exponent x minus 2 is equal to 81 exponent minus 1. Now, our main goal is to make sure that the term on the left hand side and the term on the right hand side has the same base. So the term on the left hand side, which is 3 exponent x minus 2, and the term on the right hand side, which is 81 exponent minus 1, has the same base so that we can equate the exponents. The base on the left hand side is 3. So the base we have on the left hand side is 3. The base on the right hand side is 81. We can't reduce 3 any further. So what we have to do is that we have to reduce 81 such that it has a base of 3. This means that 3 exponent a certain number will give us 81 and we need to find that number. So we are going to do that with our calculator. So you should show your calculator. We are looking for 3 exponent a certain number that will give us 81. So I'm going to try with 3. 3 exponent 3 will give us 27. 27 is smaller than 81, so I will increase the exponents. I will increase it to say 4 and see. Now, if you find 3 exponent 4 on your calculator, you will get 81, which means that the number I'm looking for is 3 exponent 4. So from here we can see that 3 exponent 4 will give us 81. Okay, so we have reduced 81 to index form such that it has a base of 3, and that is 3 exponent 4. So we can replace the 81 in this equation with 3 exponent 4. So on the left hand side we have 3 exponent x minus 2 is equal to 81 is now 3 exponent 4. Don't forget that there's already a minus 1 there. So we have 3 exponent 4 times minus 1. And this is going to give us 3 exponent x minus 2 is equal to 3 exponent minus 4. So since the base on the left hand side is 3 and the base on the right hand side is 3, we can equate the exponents. The exponent on the left hand side is x minus 2. The exponent on the right hand side is minus 4. So we can equate those two. So x minus 2 is equal to minus 4. From here, it becomes a simple linear equation. X is equal to minus 4 plus 2, and x is equal to minus 2. So the main goal here is to make sure that the term on the left hand side and the term on the right hand side has the same base, so that you can equate the exponents and find the variables or the variable in the equation. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to solve another question on exponential equations reduced to linear equations. We are on the topic indices. In the previous video, we solved a question on exponential equations that can be reduced to a linear equation. In this video, we are going to solve another question. So let's consider our question for this video. We have 8 exponent x is equal to 2 square root of 2. So we are supposed to find the value of x in this equation. We learned from sets that 2 square root of 2 can be written as 2 times square root of 2. So 8 exponent x is equal to 2 times square root of 2. Any number that is written without an exponent is having an exponent of 1. So if you see 2 is the same as 2 exponent 1. We also learned from the properties of indices that square root of 2 can be written as 2 raised to the power 1 divided by 2, or 2 raised to the power half. So 2 here is the same as 2 exponent 1. Square root of 2 can also be written as 2 exponent half. We have 2 here, we have 2 here. They are multiplying. We learned from the laws of indices that if you have two numbers in index form that have the same base, if the two numbers have the same base and they are multiplying, you write one of the bases, then you add the exponents. So 2 exponent 1 times 2 exponent half is the same as 2 exponent 1 plus half. So we have 8 exponent x is equal to 2 exponent 1 plus half. 1 plus half is the same as 3 divided by 2. So you have 8 exponent x is equal to 2 exponent 3 divided by 2. Now we have one term on the left hand side and one term on the right hand side. Remember, our main goal here is to make sure that the term on the left hand side, which is this, and the term on the right hand side, which is this, has the same base. The term on the left hand side has a base of 8. The term on the right hand side has a base of 2. So we have to express one in terms of the other, or we have to express one in index form such that it has the base of the other. So we are going to express 8 since it is the biggest one. In terms of, we are going to express 8 in index form such that it has a base of 2. So it means that 2 raised to the power a certain number will give us 8. If you do that on your calculator, you will see that if you find 2 raised to the power 3, you will get 8. It means that 8 is the same as 2 raised to the power 3. So 2 raised to the power 3 is equal to 8. So we can replace 8 here with 2 raised to the power 3. Okay, and that is exactly what we are going to do. Don't forget that there is already an x here. So we have 2 raised to the power 3 times x is equal to 2 raised to the power 3 divided by 2. And this will give us 2 raised to the power 3x is equal to 2 raised to the power 3 divided by 2. So once again, the term on the left hand side and the term on the right hand side has the same base. So now we can equate the exponents. The exponent on the left hand side is 3x. The exponent on the right hand side is 3 divided by 2. So 3x is equal to 3 divided by 2. This becomes a simple linear equation for us to solve. To do that, I'll multiply the left hand side by 2, then I'll multiply the right hand side by 2, and this will help me to cancel off the 2. 3x times 2 will give us 6x. 2 and 2 are gone, so we are left with 3 here. So 6x is equal to 3. From linear equations, we have learned that to find x, we have to divide the left hand side here by 6, and we divide the right hand side here by 6. So we have 6x divided by 6 is equal to 3 divided by 6. And when we do that, x will give us 1 divided by 2, or half. So you see that we have been able to find the value of x as half. The main goal here once again is to make sure that the term on the left hand side and the term on the right hand side, they all have the same base, so that you can equate the exponents and solve the resulting linear equation. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to solve another question on exponential equations that can be reduced to linear equations. We are still on the topic indices. In the previous video, we solved a question on exponential equations that can be reduced to a linear equation. In this video, we are going to solve another question. So let's consider a question for this video. We have 4 exponent x plus 2 is equal to 8 exponent x minus 1. And we are going to find the value of x in this equation. You can see from the previous examples that we've solved that in each of those examples, we change just one of the bases. So you see that we change the base on the left hand side so that it becomes the same as the one on the right hand side. Or we change the one on the right hand side so that it becomes the same as the one on the left hand side. Sometimes you have to change both the base on the left hand side and on the right hand side, and this is an example. Now we can see from here that the base on the left hand side is 4. The base on the right hand side is 8. It means that we have to change one such that they will have the same base. But we can't express 8 such that it has a base of 4, because 4 exponent 1 is 1. Is 4, sorry. 4 exponent 2 is 16. So we can't express 8 such that it has a base of 4. When that happens, we also can't express 4 such that it has a base of 8. So when that happens, you have to change both of them such that they will have the same base. 2 exponent 2 will give us 4. 2 exponent 3 will give us 8. So you see, if we use 2 exponent 2 for 4 and we use 2 exponent 3 for 8, both the term on the left hand side and the term on the right hand side will have the same base, and that is what we want to achieve. So the main goal here, as I've been saying all along, is to make sure that the term on the left hand side and the term on the right hand side has the same base. If you can't change the one on the left hand side to have the same base as the one on the right hand side, or you can't change the one on the right hand side to have the same base as the one on the left hand side, then it means that you have to change both of them so that they will all have the same base. So in this example, we can change 4 to 2 exponent 2. We can also change 8 to 2 exponent 3. When we do that, the term on the left hand side will have a base of 2. The term on the right hand side will also have a base of 2. So we can now equate them. So, and that is what we are going to do. So 4 is the same as 2 exponent 2. Don't forget that there's already an exponent x plus 2 there. So 2 times x plus 2. And because x plus 2 is a binomial, we explained in algebra that if you have a single term multiplying a binomial, you put the binomial in a bracket. A binomial is a term with a mathematical expression with two terms. So here we have x and 2, so x plus 2. So we are going to put the one with two terms in a bracket. Then the 2 which is multiplying it will be outside the bracket. So we have 2 into bracket x plus 2 is equal to, when you come to this side, to 8 is now 2 exponent 3. So 2 exponent 3 times, it's also multiplying a binomial which is x minus 1. So you put the binomial in a bracket. If you watch the video on algebra, we explained what a binomial is into details there. So we have 2 exponent 2 into bracket x plus 2 is equal to 2 exponent 3 into bracket x minus 1. So the base on the left hand side is 2, the base on the right hand side is 2. We can equate the exponents. The exponent on the left hand side is 2 into bracket x plus 2. The exponent on the right hand side is 3 into bracket x minus 1. So we have 2 into bracket x plus 2 is equal to 3 into bracket x minus 1 because the bases are the same. This is a linear equation. So we solve this linear equation. You open the brackets, you have 2x plus 4 is equal to 3x minus 3. You group like terms and you simplify. When you do that, you have 4 plus 3 is equal to 3x minus 2x, and x is equal to 7 from here. So the main goal, as we have been saying all along, is to make sure that the term on the left hand side and the term on the right hand side has this, or all of them, they have the same base. If they have the same base, then you can equate the exponents. We did that for this question, and we have x is equal to 7. Thank you for watching this video. Don't forget to like and subscribe to this channel. In the next video, we are going to solve another question on exponential equations that can be reduced to a linear equation. We are still on the topic indices. In the previous video, we solved a question on exponential equations that can be reduced to a linear equation. In this video, we are going to solve another question. So let's look at our question for this video. We have 2 times 4 exponent 1 minus x is equal to 8 exponent minus x. And we are supposed to find the value of x in this equation. If you look at the equation carefully, you will see that on the left hand side we have a base of 2, we also have a base of 4. On the right hand side we have a base of 8. We have to make sure that all of these have the same basis so that we can equate the exponents. We know that we can change 4 so that it has a base of 2 because 4 is the same as 2 exponents 2. We can also change 8 to have a base of 2. 8 is the same as 2 exponent 3. So when we do that, we have 2 here. We can change 4 to also have a base of 2, and we can change 8 to also have a base of 2. When we do that, we can simplify, then we equate our exponents and solve for x. So that is what we are going to do. Remember that 2 is the same as 2 exponent 1 times 4 is now 2 exponent 2. We already have a binomial which is 1 minus x here, so 2 will multiply 1 minus x. So we put 1 minus x in a bracket. Is equal to 8 is the same as 2 exponent 3. There's already minus x here, so 2 exponent 3 times minus x. This will give us 2 exponent 1 times, when you open the bracket here, we have 2 minus 2x is equal to 2 exponent minus x. We learned from the laws of indices that if you have two numbers in the index form and these two numbers are multiplying and they have the same base, you add the exponents. You write one of the bases, then you add the exponents. So we have 2 exponent 1 times 2 exponent 2 minus x. They have the same base. They are multiplying. So you write one of the twos, you write one of them, then you add the exponents. So you have 2 exponent 1 plus 2 minus 2x is equal to 2 exponent minus 3. So we have one term on the left hand side, we have another term on the right hand side. They have the same base 2, 2, so we can equate the exponents. The exponent on the left hand side is 1 plus 2 minus 2x. The exponent on the right hand side is minus 3x. So we have 1 plus 2 minus 2x is equal to minus 3x. This becomes a simple linear equation for us to simplify. So if you are simplifying this, you are going to have 3 minus 2x is equal to minus 3x. We group like terms, you will have minus 2x plus 3x is equal to minus 3. And x will give us minus 3. So once again, the main goal is to make sure that the term on the left hand side and the term on the right hand side, they all have the same base. If they have the same base, you can equate the exponents and solve the resulting linear equation. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to learn how to solve exponential equations that can be reduced to simultaneous equations. We are still on the topic indices. In the previous video, we learned how to solve exponential equations that can be reduced to a linear equation. In this video, we are going to learn how to solve exponential equations that can be reduced to a simultaneous equation. We have two questions here. We will solve the first question in this video, then we will solve the second question in the next video. So let's consider the first question. 3 exponent x divided by y is equal to 1 divided by 81, and 2x plus y is plus 3y is equal to 3, and we are supposed to find the value of x and y in these two equations. You can see that the second equation is not in index form. The second equation was given to us as a linear equation. So you have to work on the first equation such that you will get the equation 1 in linear form, and you will solve equation 1 and equation 2 simultaneously. I hope that is clear. The second equation here is a linear equation. It's not in the index form. But the first equation here is in the index form. So you have to reduce this one here to a linear equation so that you will solve equation 1 and equation 2 simultaneously to find the value of x and y. Okay, so let's consider the first equation. 3 exponent x divided by y is equal to 1 divided by 81. We learned from the properties of indices that 1 divided by 81 is the same as 381 exponent minus 1. So 3 exponent x divided by y is equal to 81 exponent minus 1. From the video on reducing exponential equations to linear equations, we said that the main goal is to make sure that the term on the left hand side and the term on the right hand side have the same base. So the term on the left hand side and the term on the right hand side have the same base, and that is exactly what we are going to do here. The base on the left hand side is 3. The base on the right hand side is 81. We can express 81 in index form such that it has a base of 3, because 3 exponent 4 is the same as 81. So when we do that, there will be a base of 3 on the left hand side and a base of 3 on the right hand side, so we can equate the exponents. So we have 3 exponent x divided by y is equal to 81 is the same as 3 exponent 4. So 3 exponent 4, there's already minus 1 here, so times minus 1. And this will give us 3 exponent x divided by y is equal to 3 exponent minus 4. So the base on the left hand side is 3, the base on the right hand side is 3. So we can equate the exponents. So we have x divided by y is equal to minus 4. And if you multiply the left hand side by y, the right hand side by y, you have x is equal to minus 4. So we have reduced this equation here to another linear equation. So this is our equation 1 and this is our equation 2. We can solve equation 1 and equation 2 simultaneously. We've learned how to solve simultaneous linear equations in the videos on solving simultaneous linear equations. So I'm going to go through it very quickly. We have x as our subject in equation 1. So straight away, I will substitute equation 1 into equation 2. So wherever I see x in equation 1, I'll replace it with minus 4y. So we have 2 times minus 4y plus 3y is equal to 3. This will give us minus 8y plus 3y is equal to 3. We have minus 5y is equal to 3. You divide both sides by minus 5 and y will give us minus 3 divided by 5. But we know from equation 1 that x is equal to minus 4y and we have just found y to be minus 3 divided by 5. So we replace my y here with minus 3 divided by 5. So x will be equal to minus 4 times minus 3 divided by 5. And we will have x is equal to 12 divided by 5. So x is equal to 12 divided by 5 and y is equal to minus 3 divided by 5. So the main thing that you need to take note here is that when you are given the two equations, reduce the two equations to linear equations and solve them simultaneously. In this question, one of the equations was already in the linear equation form, so we had to reduce just one equation. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. At the beginning of this video, we had two questions and we've solved the first one. In the next video, we are going to solve the other one. We are still on the topic indices. In the previous video, we solved a question on exponential equations that are reduced to simultaneous equations. In this video, we are going to solve another question. So let's consider the question for this video. We have 4 exponent 4 minus x is equal to 2 exponent 1 minus y. And 3 exponent x plus y is equal to 9 exponent minus y. So we have these two exponential equations and we are supposed to find the value of x and y. As we saw in the previous video, when you have an exponential equation like this, what you have to do is to reduce the first equation to a linear equation and reduce the second one also to a linear equation. So let's start with the first one. 4 exponent 4 minus x is equal to 2 exponent 1 minus y. The base on the left hand side is 4. The base on the right hand side is 2. We can express 4 in index form such that it has a base of 2 because we know that 2 raised to the power 2 is the same as 4. When we do that, the base on the left hand side will be 2. The base on the right hand side will also be 2. So we can equate the exponents. So 4 is the same as 2 exponents 2. Don't forget that we already have 4 minus x here, which is a binomial. So if 2 is multiplying a binomial, you put the binomial in a bracket. So we have 2 exponents 2 into bracket 4 minus x is equal to 2 exponent 1 minus y. So the base on the left hand side is now 2. The base on the right hand side is also 2. so we can equate the exponents. So we have 2 into bracket 4 minus x is equal to 1 minus y. We open the bracket here, we will have 8 minus 2x is equal to 1 minus y. Let's group like terms. So minus x plus y is equal to 1 minus 8. And we have minus 2x plus y is equal to minus 7. So we have reduced this first equation here to a linear equation. Let's consider the second one. We have 3 exponent x plus y is equal to 9 exponent minus y. We have to make sure that the base on the left hand side and the base on the right hand side are all the same. We can express 9 in index form such that it has a base of 3. 9 is equal to 3 exponent 2. So 3 exponent x plus y is equal to 3 exponent 2 times minus y, because 9 is 3 exponent 2. This will give us 3 exponent x plus y is equal to 3 exponent 2 times minus y is minus 2y. The base on the left hand side is now 3. The base on the right hand side is also 3. So we can equate the exponents. So we have x plus y is equal to minus 2y. If we simplify this, we have x is equal to minus 2y minus y. So x is equal to minus 3y. We know this from algebra. We have the equation 1, we have equation 2. So we have reduced the first equation here to a linear equation, giving us equation 1. And we have reduced the second equation also to a linear equation, giving us equation 2. So we solve these two equations simultaneously. We've studied how to solve simultaneous linear equation under the videos on solving simultaneous linear equations. We learned how to use the substitution method, the elimination method, and the graphical method. So I'll go through solving these equations quickly. I have x is equal to minus 3y as equation 2. So I'm going to use the substitution method. So I'll substitute equation 2 into equation 1. So this will give us minus 2 times minus 3y plus y is equal to minus 7. We will have 6y plus y is equal to minus 7. So 7y is equal to minus 7. You divide both sides by 7 and y is giving us minus 1. But we know from equation 2 that x is equal to minus 3y. We just found y as minus 1. So we can replace y with minus 1 to find x. So x is equal to minus 3 times minus 1. And x will give us 3. So we have x is equal to 3, y is equal to minus 1. If you want to understand how to solve simultaneous equations, watch the video on simultaneous linear equations. We learned how to use all 3 methods to solve simultaneous equations. So once again, we have reduced these exponential equations to linear equations, and we solve the resulting equations simultaneously. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to learn how to solve exponential equations that are reduced to quadratic equations. We are still on the topic indices. In the previous video, we learned how to solve exponential equations that are reduced to simultaneous equations. In this video, we are going to learn how to solve exponential equations that are reduced to quadratic equations. We have 5 questions here. So we are supposed to solve for x in the following equations. We will solve the first one in this video, and we will solve the others in the subsequent videos. So let's consider the question for this video. 3 exponent x squared minus 1 is equal to 9 exponent 4. As we've been doing all along, when we are given this exponential equation, our main goal is to make sure that the base on the left hand side and the base on the right hand side are the same, so that we can equate the exponents. The base on the left hand side is 3. The base on the right hand side is 9. We can express 9 in index form such that it has a base of 3, because 9 is equal to 3 exponent 2, or 3 squared. So if we change 9 to 3 squared, we will have the base on the left hand side as 3 and the base on the right hand side as 3. Then we can equate the exponents. So we have 3 exponent s squared minus 1 is equal to 9 is 3 exponent 2. So 3 exponent 2 times 4, because we already had a raised to the power 4 here, or an exponent of 4 here. Okay, this will give us 3 exponent s squared minus 1 is equal to 3 exponent 8, because 2 times 4 is 8. Now, the base on the left hand side is 3. The base on the right hand side is also 3. So we can equate the exponents. The exponent on the left hand side is s squared minus 1. The exponent on the right hand side is 8. So s squared minus 1 is equal to 8. If I bring 8 from this side to this side, from the right hand side to the left hand side, you have s squared minus 1 minus 8 is equal to 0. This will give us s squared minus 9 is equal to 0. 9, as you can see from here, can be written in the index form as 3 squared. So you have s squared minus 3 squared is equal to 0. In the videos on algebraic expressions, we studied difference of two squares. If you watch that video, you will see that this expression s squared minus 3 squared is an example of a difference of two squares. In that video, we learned how to expand difference of two squares. So we are going to use what we've studied in that video here. So to expand this difference of two squares, you have x minus 3 in one bracket, then x plus 3 in the other bracket is equal to 0. So in the video on difference of two squares, we explained how to expand difference of two squares. If you want more information about that, you can watch that video under quadratic expressions. We treated difference of two squares there. S squared minus 3 squared is an example of difference of two squares. So in expanding this difference of two squares, you have x minus 3 in one bracket, then x plus 3 in the other bracket is equal to 0. So we have this x minus 3 in one bracket, x plus 3 in the other bracket is equal to 0. To find x, we will equate the first expression here to 0, then we find x for that. Then we will equate the second expression to 0, then we will find x for that one also. So the first one, we have x minus 3 is equal to 0. So x is equal to 3. That is the first instant. Then we will equate the second one also to 0. We have x plus 3 is equal to 0. So x is equal to minus 3. So since it's a quadratic equation, you are going to have two answers for x. So we can say that x is equal to 3 or minus 3. So once again, the main principle here is to make sure that the term on the left hand side and the term on the right hand side, they all have the same basis, so that you can equate the exponents. Thank you for watching this video. Don't forget to like and subscribe to this channel. In the next video, we are going to solve another question on exponential equations that are reduced to quadratic equations. We are still on the topic indices. In the previous video, we solved a question on exponential equations that can be reduced to a quadratic equation. In this video, we are going to solve another question. Let's consider the question for this video. We have 1 divided by 4 exponent 3x squared plus 1 is equal to 128 exponent x. We learned from the properties of indices that 1 divided by 4 can be written as 4 exponent minus 1. So we have 4 exponent minus 1 multiplying this exponent here. Now this exponent is a binomial. Since we have 1 multiplying it, since we have negative 1 multiplying it, you are going to put the binomial in a bracket. So you have 4 exponent minus 1 into brackets 3x squared plus 1 is equal to 128 exponent x. The main goal here is to make sure that the term on the left hand side and the term on the right hand side, they have the same base. The term on the left hand side has a base of 4. What we have on the right hand side has a base of 128. So we have to make sure that they have the same base. We can't express 128 in index form such that it has a base of 4. But what we can do is that we can express 128 in index form such that it has a base of 2. We can also express 4 in index form such that it has a base of 2. When we do that, the term on the left hand side and the term on the right hand side will have the same base. So if you express 4 in index form such that it has a base of 2, we are going to have 2 exponent 2. So we have 2 exponent 2 times, we already have this as the exponent, which is minus 1 into bracket 3x squared plus 1. Then is equal to 128. If you express it in index form such that it has a base of 2, you have 2 exponent 7. 2 exponent 7 will give us 128. We already have an exponent of x here, so 2 exponent 7 times x. 2 times minus 1 will give us minus 2. So you have 2 exponent minus 2 into bracket 3x squared plus 1 is equal to 2 exponent 7x, because 7 times x will give us 7x. Now, we have the term on the left hand side having a base of 2. We have the term on the right hand side having the base of 2. So we can equate the exponents. So you say that minus 2 into bracket 3x squared plus 1 is equal to 7x. We expand this bracket. You have minus 6x squared minus 2 is equal to 7x. This is a quadratic equation. So we arrange it well so that you'll be able to solve the quadratic equation. So I'll take all the terms on the left hand side to the right hand side. So you have, if I take everything from here, you'll be left with 0. So 0 is equal to 7x plus 6x squared plus 2. Rearranging it, you have 6x squared plus 7x plus 2 is equal to 0. In the videos on quadratic expressions, we learned how to factorize quadratic trinomial. The expression we have on the left hand side here is a quadratic trinomial. So we are going to factorize this quadratic trinomial in order to find x. In that video, we saw that to factorize this quadratic trinomial, you multiply 6 by 2. 6 times 2 will give us 12. So we are looking for two numbers that when you multiply, you get 12. When you add them, you get 7. Once again, in the video on quadratic trinomials and the algebraic expressions, I explained how to factorize quadratic trinomials. So I'll go ahead with the factorization here. If you want to learn how to factorize quadratic trinomials, watch the video on quadratic trinomials and the algebraic expressions, and you will get how to do that. Okay, so we are looking for two numbers that when you multiply, you get 12. When you add, you get 7. Those two numbers are 3 and 4. So you place 7x with 3x and 4x. You have 6x squared plus 3x plus 4x plus 2 is equal to 0. So we are going to factorize this expression here. I'll put brackets around the first two, then I'll put brackets around these two also. Here we will factorize 3x out, giving us 3x into brackets 2x plus 1. You close the bracket, plus here you factorize 2 out, so 2 into bracket 2x plus 1 is equal to 0. We have 2x plus 1 here, 2x plus 1 here, so you write one of them, then you write 3x plus 2 in the other brackets. So we have 3x plus 2 in one bracket, 2x plus 1 in the other bracket is equal to 0. As I said, if you want to learn or understand how to factorize quadratic trinomials, watch the video on quadratic trinomials and the algebraic expressions. I explain that into details there. So we have factorized this quadratic trinomial. To find x, we equate the first expression here, which is 2x plus 3x plus 2 to 0. So we have 3x plus 2 is equal to 0. Then we also equate the second one, which is 2x plus 1 is equal to 0. So you have 3x is equal to minus 2. When you come here, so you have 2x is equal to minus 1. We divide the left hand side here by 3, the right hand side here by 3, and x will give us minus 3 divided by 2. When you come here to you divide the left hand side by 2, the right hand side by 2, and you have x is equal to minus 1 divided by 2. So we have x is equal to minus 2 divided by 3, and x is equal to minus 1 divided by 2. So here, the most important thing is to make sure that the term on the left hand side and the term on the right hand side has the same base. If they have the same base, you can equate the exponents. Now, when you do that, you have to solve the resulting quadratic equation. This is an example of a quadratic equation. In the video on algebraic expressions, I explained how to factorize quadratic equations. So if you learn that very well, you'll be able to factorize the resulting quadratic equations and find the value of the variables in the equation. So we have x is equal to minus 2 divided by 3 or minus 1 divided by 2. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to solve another question on exponential equations that can be reduced to quadratic equations. We are still on the topic indices. In the previous video, we solved a question on reducing exponential equations to quadratic equations. In this video, we are going to solve another question. The question for this video is 2 exponent 2x plus 3 into bracket 2 exponent x minus 4 is equal to 0. If you look at this example very carefully, it's quite different from all the examples that we've been solving so far. So when you are given a question of this nature, how do you solve it? The first thing you need to do is to rearrange the equation. Now, what does that mean? You see, we have 2 exponent 2x. 2 exponent 2x can also be written as 2 exponent x in a bracket, then exponent 2. We have plus 3 into bracket 2 exponent x minus 4 is equal to 0. So we have 2 exponent x in this bracket. We have 2 exponent x in this bracket also. Now, after you've arranged the equation like this, you have to let a variable represent what you have in the bracket here. So what we have in the bracket here is 2 exponent x. We have 2 exponent x in this bracket also. So you let a variable you are going to write a variable to represent 2 exponent x. So that's what I mean. Let 2 exponent x is equal to a, which means that wherever you see 2 exponent x, you will replace it with a. This will help us to get the quadratic equation so that we will be able to solve the question. Okay, so we have 2 exponent x here. We are saying that 2 exponent x is now a. So a squared, or we have replaced 2 exponent x here with a. So a raised to the power 2 plus 3 into bracket 2 exponent x is now a. So 3 into bracket a minus 4 is equal to 0. This will give us a squared plus 3x minus 4 is equal to 0. This is a quadratic equation. So we are going to solve this quadratic equation. To do that, we factorize this quadratic trinomial here. We've learned how to factorize quadratic trinomials in the videos on algebraic expressions. So I'm going to go ahead and factorize this trinomial here. So you have, if you factorize this trinomial, you are going to have a minus 1 in one bracket, then a plus 4 in the other bracket, you have is equal to 0. If you want to learn how to factorize this quadratic trinomial, watch the video on factorizing quadratic trinomials under algebraic expressions. I explained how to factorize a quadratic trinomial there. So if you factorize this trinomial, you have a minus 1 in one bracket, a plus 4 in the other bracket. You have is equal to 0 here. So a minus 1 in one bracket, a plus 4 in the other bracket is equal to 0. To find a, you equate the first one here, which is a minus 1 to 0. So you have a minus 1 is equal to 0. A will give us 1. Then a plus 4 is equal to 0. So a will give us minus 4. Remember, we are not interested in finding a. The question told us to find x. We introduce a in order to help us find x. Now, what is a? At the beginning of our solution, we said that a is equal to 2x. We have now found a, so you can use the a to find x. Okay, so you see we have two values for a here. It means that we are going to find x in both cases. So in the first case, when a is equal to 1, if you replace 1 a here with 1, you have 1 is equal to 2 exponent x. In the properties, when we were studying the properties of indices, we learned that any number exponent 0 is 1. So 1 here can also be written as 2 exponent 0. So you have 2 exponent 0 is equal to 2 exponent x. The term on the left hand side is 2. The term on the right hand side is 2. So we can equate the exponents. So we say that 0 is equal to x, or x is equal to 0. So we have found x in the first instance, and we have x to be 0. We are going to consider x for the second instance because a is both 1 and minus 4. We have found x for when a is 1. So let's find x for when a is minus 4. When a is minus 4, we will have minus 4 is equal to 2 exponent x because a is now minus 4. So minus 4 is equal to 2 exponent x. But we can't express minus 4 in index form such that it has a base of 2. Remember that minus 4 is not equal to 2. Minus 4, if you express minus 4 in exponent form, we are going to have this minus 2 exponent 2. But the expression here is minus 4 is equal to 2x. So we are going to have minus 2 exponent 2 is equal to 2x. Now, look at something here. You will see that the term on the left hand side has a base of minus 2. The term on the right hand side has a base of 2. 2 and minus 2 are not the same, so we can't equate the exponents, which means that because we can't equate the exponents here, or we can't express the term on the left hand side and the term on the right hand side to have the same base, we can't go on further with our solution here. So x is 0. It means that for this question here, we will have only one answer for x, and x is equal to 0. We did that because we can't break this expression here any further. So you have x is equal to 0 for this expression. So if you have been given this type of question as we had in this video, the first thing you need to do is to rearrange the equation. Then you will let a variable to represent the expression that you have in the bracket. You solve the resulting quadratic equation. Then you find the value of the variable in the question. Thank you for watching this video. In the next video, we are going to solve another question of this type. We are still on the topic indices. In the previous video, we solved a question on reducing exponential equations to quadratic equations. In this video, we are going to solve another question. So let's consider our question for this video. The question is 2 exponent 2x plus 1 minus 9 into bracket 2 exponent x plus 4 is equal to 0. As we learned in the previous video, we said that when you are given an expression like this, the first thing you need to do is to rearrange the equation. We know from the properties of indices that 2 exponent 2x plus 1 can also be written as 2 exponent 2x times 2 exponent 1. Because if you have two numbers in index form and these two numbers are multiplying and they have the same base, you can add the exponents. So if you have 2 exponent 2x times 2 exponent 1, we can write one of the bases here as 2, then we add the exponents. So 2 exponent 2x times 2 exponent 1 is the expanded form of 2 exponent 2x plus 1. So you've not changed anything. So we have 2 exponent 2x times 2 exponent 1 minus 9 into bracket 2 exponent x plus 4 is equal to 0. If you rearrange this equation, you have 2 exponent 2x can also be written as 2 exponent x in a bracket, then exponent 2. Times, we have 2 exponent 1 here, minus 9 into bracket 2 exponent x plus 4 is equal to 0. So you see that you have 2 exponent x in this bracket, we have 2 exponent x in this bracket also. So we are going to represent 2 exponent x by a variable. We are going to replace it by a variable. So I will say that let 2 exponent x is equal to n. That means that wherever you see 2 exponent x, you replace it with n. Okay, so we have 2 exponent x here, so you replace that with n. So you have n exponent 2 times 2 exponent 1 is 2 minus 9 into bracket. You have 2 exponent x here, we are replacing it with n. So 9 into bracket n plus 4 is equal to 0. This will give us n squared times 2. N squared times 2, we learned from algebra that is written as 2n squared minus 9 times n will give us 9n plus 4 is equal to 0. Once again, we have another quadratic equation. To solve this quadratic equation, we have to factorize the quadratic trinomial on the left-hand side here. In the videos on algebraic expressions, I explained how to factorize quadratic trinomials. So I'm going to go through quickly with the factorization. We will have 2n squared minus 8n minus n plus 4 is equal to 0. If we simplify this, we are going to have 2n into bracket n minus 4 minus 1 into bracket n minus 4. Now, this will give us 2n minus 1 in one bracket, then n minus 4 in the other bracket. Okay, so we have 2n minus 1 in one bracket, n minus 4 in the other bracket. You have is equal to 0 here. We need to find n. So you equate the first bracket to 0. So 2n minus 1 is equal to 0. 2n will give us 1. You divide both sides by 2 and n will give us 1 divided by 2. Then you equate the second bracket to 0. So you have n minus 4 is equal to 0. So n is equal to 4. So we have found when n is equal to 2 and when n is equal to 4. Remember, we only introduced n to help us find x. At the beginning, we said that n is equal to 2 exponent x. So we are going to find x for when n is equal to 1 divided by 2 and when n is equal to 4. Let's consider for the first case. When n is equal to 1 divided by 2, we can say that 1 divided by 2, which is half, is equal to 2 exponent x. We learned from the properties of indices that half can be written as 2 exponent minus 1. So we have 2 exponent minus 1 is equal to 2 exponent x. The expression on the left hand side is 2. The expression on the right hand side is also 2. Sorry, the base on the left hand side is 2. The base on the right hand side is also 2. So we can equate the exponents. So we have x is equal to minus 1, or minus 1 is equal to x. This is for when n is equal to 1 over 2, or half. Let's consider for when n is equal to 4, because that is another instant. So when x is equal to 4, you have 4 is equal to 2 exponent x. Remember, in the index form, 4 can be written as 2 exponent 2. So 2 exponent 2 is equal to 2 exponent x. The base on the left hand side is 2. The base on the right hand side is also 2. Okay, so we can equate the exponents. So we have x is equal to 2, or 2 is equal to x. So we have been able to find x. We found x to be equal to minus 1 or 2. So all you need to do here is to rearrange the equation very well. After that, you let a variable represent what you have in the bracket. Then you find the new variable that you introduce. After you found that, you will be able to use the values of the new variable that you introduce to find the variable in the equation. Here, the variable in the equation was x. So we introduced n to help us find x. We found two values for n. After that, we use these two values for n to find two values for x. So x is equal to minus 1 or 2. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to solve another question on exponential equations that are reduced to quadratic equations. We are on the topic indices. This is going to be the last video on indices. In the previous video, we learned how to reduce exponential equations to quadratic equations and solve the resulting quadratic equation. In this video, we are going to solve another question on reducing exponential equations to quadratic equations. Let's consider our question for this video. We have 2 exponents 2x plus 1 minus 5 into brackets 2 exponent x plus 2 is equal to 0. As we learned in the previous video, when you are given a question of this nature, you first have to rearrange the equation. 2 exponent 2x plus 1 can also be written as 2 exponent 2x times 2 exponent 1. So you have minus 5 into bracket 2x plus 2 is equal to 0. 2 exponent 2x can also be written as 2 exponent 2x can also be written as 2 exponent x in a bracket, then exponent 2 times 2 exponent 1 minus 5 into brackets 2x plus 2 is equal to 0. We have 2 exponent x in these two brackets. So we are going to represent 2 exponent x with a variable. We are using the variable y. So let 2 exponent x equal to y, which means that where we see 2 exponent x, you replace it with y. This will give us y exponent 2 times 2 minus 5 into bracket y plus 2 is equal to 0. When we simplify this, we will have 2y squared minus 5y plus 2 is equal to 0. We have another quadratic equation on our hands. To solve this quadratic equation, we factorize the quadratic trinomial on the left-hand side. I explained how to solve quadratic trinomials. I explained how to factorize quadratic trinomials in the videos on algebraic expressions. So I'm going to go ahead with factorizing this quadratic trinomial. You have 2y squared minus 4y minus y plus 2 is equal to 0. This will give us 2y squared minus 4y in one bracket minus into bracket y minus 2 is equal to 0. In factorizing this, we are going to have 2y into bracket y minus 2 minus 1 into bracket y minus 2. And this will give us 2y minus 1 in one bracket, y minus 2 in the other bracket, equal to 0. So we have 2y minus 1 in one bracket, y minus 2 in the other bracket is equal to 0. We equate the first bracket to 0. So we have 2y minus 1 is equal to 0, 2y is equal to 1, y will give us 1 divided by 2, or half. We equate the second bracket also to 0. So we have y minus 2 is equal to 0, y is equal to 2. So we have found y. Remember, we introduced y. The question told us to find x. But what is y? Y is 2 exponent x. So we are going to find x for when y is equal to 1 divided by 2 and when y is equal to 2. Okay, so when y is equal to 1 divided by 2, you have 1 divided by 2 is equal to 2 exponent x. From the video on properties of indices, we learned that 1 divided by 2 can also be written as 2 exponent minus 1. So 2 exponent minus 1 is equal to 2 exponent x. We have the base on the left hand side as 2, the base on the right hand side as 2. So you can equate the exponents and say that x is equal to minus 1. This is for when y is equal to 2. Sorry, this is for when y is equal to half. When y is equal to 2, you have 2 is equal to 2 exponent x. Remember that 2 can also be written as 2 exponent 1 because any number exponent 1 is the same number. So 2 is equal to 2 exponent 1. So you have 2 exponent 1 is equal to 2 exponent x. The base on the left hand side is 2. The base on the right hand side is 2. So you can equate the exponents. So x is equal to 1. So solving this quadratic trinomial, solving this quadratic equation, we have been able to find x as minus 1 or 1. So the most important thing here is to rearrange the equation. After that, you let the variable represent what you have in the brackets. After you solve the new value or the new variable that you introduce, you can use the values for the new variable, in this case y is equal to half and y is equal to 2, to find the variable in the question. The variable in the question was x. So you use 1, y is equal to half and y is equal to 2 to find the values of x, and we had x is equal to minus 1 or 1. Thank you for watching this video on indices and all the videos on indices. Pick more examples and try your hands on them. If you have any problem solving any of the questions, don't hesitate to interact with me on my social media handles and I'll help you. Subscribe to this channel for more videos.